Alright, so this is the second video that I'm going to do on simplifying trig expressions. The first video had just kind of a quick overview of what the identities were, just some of the identities, and then also I talked about substitution and factoring trig expressions and how those can work together. In this video I'm going to talk about adding and subtracting, and then also multiplying by the conjugate, and I'll do an example of each kind. And so here's the identities again, just in case you found this video and you need to see them. The first six are your reciprocal identities. They're pretty straightforward. Quotient identities are in the middle there. And then obviously the Pythagorean identities. Those are going to play a real important role in this video, hopefully, especially when we multiply by the conjugate. And I'll talk about that more, and we'll kind of go from there. So here we go. So the first thing we're going to do is we're going to talk about simplifying trig expressions and using addition or subtraction. So you may see a trig expression where you see addition or subtraction, and what you're going to have to do is kind of think about how you could add or subtract those things together. So take this one for example, cosine of x minus cosine of x over 1 minus tangent of x. So you look at that and you say, okay, obviously this first piece is just cosine of x, but this piece is a whole fraction. So if we think to ourselves, how do we subtract fractions? What we do is we get common denominators. So we're going to need to take this first cosine, put it over 1, and we're going to have to multiply by 1 minus tangent of x on top and bottom. So 1 minus tangent of x here, and 1 minus tangent of x. And so now what's that going to give us? That's going to give us cosine. If I distribute the cosine to 1 minus tangent of x, that's going to give me cosine of x minus cosine of x times tangent of x all over 1 minus tangent of x, and then subtracted by cosine of x over 1 minus tangent of x. And so if we're taking a look at that, now we have similar same denominators, and we can combine the numerators. When you look at the numerators, hopefully you see that this guy here and this cosine are going to be like terms. So cosine minus cosine is going to be 0. So on the numerator, all I'm going to have is negative cosine of x times tangent of x. Well, that's an x. Let's pretend that's an x. All over 1 minus tangent of x. So you may say to yourself, okay, am I done? Is that simplified? And I guess the question is there anything that you can do? Like if I multiply cosine times tangent, is that somehow going to simplify? And I would argue that it does. And so if you think of tangent, right, negative cosine of x is what we have, but tangent is sine of x over cosine of x, right? So now this is on the numerator, still with 1 minus tangent of x on the denominator. Then we see that the cosines would reduce, and we would just have negative sine of x on the bottom and 1 minus tangent of x, or excuse me, negative sine of x on top and 1 minus tangent of x on the bottom. And so I'd say that's probably simplified enough. You probably don't need to go any further than that unless you were kind of trying to solve for an identity and then it had something else on the other side that you needed to make it look like. But remember, when you're adding or subtracting, the real key is that you need common denominators, and then you're trying to simplify the numerator. So first get common denominators, right? Common denominators, that's the bottom. So multiply by whatever factors they need, get that, and then after you get that correctly, then you'll need to simplify the numerators. And then you just look for ways to simplify after that. So that seems pretty good. Alright, let's talk about this idea of multiplying by the conjugate, because it becomes very useful when you simplify trig expressions, but more importantly it becomes very useful when you are verifying trig identities. So it's called multiplying by the conjugate. And so first, if you don't know what the conjugate is, conjugate is just this term that we use in math to say, like, if there's two terms being added, a plus b, then the conjugate is a minus b, and vice versa. So if you have a plus b, it goes to, the conjugate would be a minus b. If you have a minus b, then the conjugate would be a plus b. And the whole point of that is that when you multiply conjugates together, a plus b times a minus b, what happens is you end up getting what we call a difference of squares situation. So you would have a times a, which is a squared, minus a times b, and then plus a times b when you FOIL it out, and then minus b squared. And since we're keeping it very general, we'll always see that the middle parts will always cancel out. So then you'll have a squared minus b squared every time when you multiply conjugates together. So it's kind of a nice way where we won't hopefully have to FOIL a lot. And so if you're trying to simplify this, you have cotangent squared of x over 1 plus cosecant of x. If we're trying to simplify that, then one way we can do it, there's lots of ways, or maybe at least a couple ways, but one way we can do it is we can multiply by the conjugate. So if you see 1 plus cosecant of x, you would then multiply by 1 minus cosecant of x on top and bottom. Oops, cosecant of x. And so the top would still be cotangent squared, and I'm going to leave it factored, 1 minus cosecant of x, over, and then you would have 1 minus cosecant squared of x. If I FOIL it out, 1 times 1 is 1, and then the two cosecants would cancel out, and then cosecant of x times negative cosecant of x is negative cosecant squared. And so now that you do this, the beauty of multiplying by the conjugate is that you should end up with something right here that should be able to use a Pythagorean identity. If you can't use a Pythagorean identity, then you probably didn't need to multiply by the conjugate. And you learn that lesson the hard way sometimes. You multiply them by each other and you're like, I thought it was going to be a Pythagorean identity, but it's not. So let's take a look at the one that comes from. 1 plus cotangent squared is equal to cosecant squared, cosecant squared of x. And so when we're looking at that, we're like, okay, that's not 1 minus cosecant squared, but I can get that by subtracting cotangent over to the right side, giving me 1 equals cosecant squared of x minus cotangent squared, and then subtracting the cosecant over, giving me 1 minus cosecant squared of x, and that equals negative cotangent squared of x. So when we look at that, I can replace 1 minus cosecant squared with negative cotangent squared. So we have cotangent squared of x times 1 minus cosecant of x all over negative cotangent squared of x. So the cotangent squareds will cancel out. Those divide to 1. And so now we have 1 minus cosecant of x divided by negative 1. And we'll divide the negative 1 into both, and that would be negative 1 plus cosecant of x. And that would be it. And so multiplying by the conjugate is something you can do with any fraction as long as there is a binomial. Here we go, right here on the bottom, right? As long as there's a binomial on the bottom, you can always multiply by the conjugate. However, sometimes it's not helpful. So one more time, I'll say this just since maybe it might be new to you. The idea here is that when you multiply by the conjugate, you're always going to get a difference of squares situation, like that. Like this guy right here. So you're always going to get a difference of squares situation. That difference of squares situation needs to come from one of these three Pythagorean identities, right? So one of these three, you need to be able to manipulate one of those three and find what you could substitute in. If you can't, then you probably shouldn't have multiplied by the conjugate. So somehow, some way, when you multiply by the conjugate, make sure you can use a Pythagorean identity, because 90% of the time you should be able to use a Pythagorean identity when you multiply by the conjugate. Alright, hopefully that was helpful. Have a great day, and maybe like and subscribe. You never know. Maybe I'll get money out of this someday. Probably not. But anyway, have a good day.